Hello everybody, my name is Hello. Welcome back to the series where we're dealing with programming and design patterns in Python. So in today's video, we're going to be talking about the strategy pattern. And as of recording this will be the final pattern that we're going to be going through, which is awesome. I don't know when this video will come out though, but yeah. So what is a strategy pattern? Well, in strategy pattern, we will be defining a family of algorithms, okay, or strategies, each in their separate class. And all of these are interchangeable at runtime. Why do you need this? What does this statement mean? Well, we need to be able to choose a behavior at runtime, or else you'll have a messy if else statement, okay, and it does not follow the open/closed principle. Now all of this, what do they mean? We look at an example of why this will not work and then try to rewrite that into a strategy pattern. Okay, so as of recording this video, the movie F1 has just come. So we'll take an example from that movie. So there they'll have three strategies for the driver, right? So they'll have plan A, plan B, and plan C, where plan C is for combat. Now let's say these are three different strategies. Now let's say I have a class called F1 driver. Okay, maybe this is a markdown. We'll try to code what that will look like first, and I have this class. Okay, then I will have maybe define. Okay, before that, let me just get syntax highlighting so that we have an idea. So we have a follow plan, and then what we'll do a self and a plan. Okay, so we'll say if this plan is equal to plan A, in that case, what can plan A be? Plan A will be the normal plan, which is just doing two pit stops. So standard 2-pit strategy. Okay, and then what is plan B? So plan B might be when there's rain in the track, right? So in that case, what we do, you just say so plan B, wet tires, so you'd want to drive cautiously, right? And then what is plan C? So oh sorry, not else, maybe we could do a elif plan C. That plan C is for combat. So plan C is for combat. Okay, and else, if there's some plan that is there that we're not mentioning, we can say unknown. Okay, now if I want to go ahead and create an instance, so I can take this F1 as the F1 driver, right? Then I'll do, and F2 will also be another F1 driver. Okay, so then here we can take maybe Sonny and Joshua, right? And we're telling the drivers to follow this particular plan. So Sonny will follow plan A, and then Joshua would follow maybe plan C, for example. Okay, lower wise this should be C and this should be A, but okay, this is what this looks like, right? So plan C is for combat, plan A is standard 2-bit strategy. This is awesome. The problem with this code, and this is without the strategy pattern is, see, this follow plan is there. Here we are using a lot of if else statements. Now there are only 3 plans, so there's 2 if else, 1 if, and then an else. What if there are 10 plans? You'd have to modify this F1 driver class, which is something that you should not do, and this is not good coding practice at all, because in the future, if you're open to experiment with new strategies, for example, that is something that will take a long time. It's messy, and adapting with all of this will be a hassle, and that is what we're saying. And at the same time, what if I want to choose a behavior at runtime? Again, this is something you can take input from the user, for example, and then maybe put this, I'm changing this to B, this will take an if else statement, but I'll have to add more if there's more strategies that are coming. Let's say I develop a strategy tomorrow, I have to develop the strategy first, then write the logic over here. So if there are 100 strategies, for example, 100 if else statements, which would be a problem again. So this open closed principle, what that means actually is, your code should always be open for new strategies but closed for modification. Now here in this case, if I have to have a new strategy, I'm going to be modifying this code, and that is something that's not allowed, as we discussed, because it'll be messy. Now with strategy pattern, again, this is markdown, maybe I'll just delete the cell, and so I'll say with strategy pattern. Okay, let us redefine all of this to have to make this make more sense, basically. Okay, so first of all, let's have base class so that we could implement from that. Okay, so as we discussed before, this we can use as an abstract class if we want to, or if we don't want to, we don't want to. Okay, so in this case maybe we won't do an abstract class because that's something that we've seen in other videos also. So if you guys want to see how to you can do that as an abstract class, you can always go there and watch. Okay, so I'm going to create a class called race plan, and this race plan will have nothing but a function called execute, and this will just be pass. Okay, because this is the base class from this class we're going to be implementing for our other class. Okay, so plan A will be from race plan, and what we'll do here is this define execute of self. What we'll do, we'll just simply go ahead and print this statement right here. Okay, now similarly I'm going to go ahead and create two other plans. So plan B, and then similarly we have plan C also, right? So plan C, here I can just paste plan C whatever I have here, and I can display plan B. Okay, done. So I have my three plans. Right now, as an F1 driver, we'd actually have to change this class a bit. Now as an F1 driver, let us go ahead and initialize this, define init self, and we have a strategy. Okay, so what this will take is self.strategy strategy will be equal to strategy. Okay, just right here. And something we can actually do is maybe define set strategy again self comma strategy. We can change, I mean add the same line. Now if you're asking why you need the same twice, I'll explain in a bit. But then we'll have our follow plan function, which just take self, and what we'll do is we will just do self dot strategy dot execute. Okay, now let us go ahead and write the same driver code as we have done before. So what I'll do here is I will do Sonny and Joshua, they're two drivers, right? So then I am actually going to create a plan B object and a plan A object and a plan C object. Okay, so rather than me doing this, putting in a parameter over here, I'm just going to go ahead and do it. So that is done, but I also have to add a parameter here. So so that will be our plan A. Plan A will be plan A, and then similarly let me just create two other classes for the other plans. So plan B, and then similarly plan C. Okay, so now let us go ahead and initialize Sonny to follow plan A, and then Joshua to follow plan A. So initially they're following plan A. Okay, now I'll just go ahead and print this. You can see that plan A, Sonny, for him, he says standard 2-pitch strategy, and plan B, Joshua, also standard 2-pitch strategy, which is the same thing as we did before. But now the advantage to that would be if I have plan D, plan E, plan E, plan F, I can just go ahead and just change this alone to that plan, and that will work. I don't have to touch this F1 driver function, and that is what we're talking about. Open to new strategies, open to expansion, but closed for modification. Expanding means like this, I can write how many ever functions I want. That doesn't really, I mean, how many ever classes I want. That there's not anything that will be messy because of that, right? But at the same time, if I add all of these things in here, that will become messy because there's a lot of effects. So that is what we're trying to do here. Okay, so this is working. The other thing, what did we talk about? Changing the behavior at runtime. Let's say in the middle of the match, just like the movie, there's some problem, and now from the comms they're announcing that Sonny, let's go ahead and change your strategy to plan C now. Okay, now Joshua will still be in plan A only. We'll go ahead and write what the follow plan looks like. Okay, you can see case 1, right, the plan A, both are doing plan A. But in case 2, once we are changing the behavior, the strategy in runtime, on the fly, basically, we are saying Sonny, you can just now he's doing plan C, which is combat, and Joshua is still following his plan A. Okay, so this is what the strategy pattern looks like, and that is why it's very, very useful in such cases. Rather than you having or dealing with messy code, you can just do all of these plans into different classes, and actually the term would be strategies into different classes, and then do something like this to just set your strategy and then go from there. Okay, we are doing this init because we're just doing that here. You can just completely remove this, and you can also keep this empty, and then you can just add this over here. So you do probably something like Sonny strategy, and then Joshua set strategy. You can do something like PA initially, right? And then you can just run this code. You can see that it's the same thing. So either you can initialize with something, or if you want to keep something similar to this, you can just add this set strategy function, and then you can go ahead and go from there and use your classes. Okay, so that is what the strategy pattern is. Again, something we talked about is defining this family of algorithms. So all of these are different algorithms, different strategies, which we are then using in this main class. Okay, now maybe some other functions that you can work with if you're trying to solve this on your own, or trying to work with the strategy pattern. You can actually take a list from the user, create one strategy for every sorting method. Okay, so you'll have bubble sort, you'll have quick sort, and you'll have insertion sort, stuff like that, right? So each of these will be their own strategy. Create a sort class there, set their strategy, and then the follow plan or the sort function from there. Then, just like how we're doing this, execute that for the user. Try to change these methods for the same objects, change these algorithms, change these strategies for the same object, and see how that looks like. Okay, maybe you could give a very large number and see how these strategies affect the runtime performance also. That's something that you can do, which again will make a lot of sense, and you will provide more of insight about this pattern and how you can use that. Okay, thank you so much for watching. I hope this video helped you. If it did, hit that like button. If you guys have any questions, let me know down in the comments. I'll try my best to answer them. As always, this code is there in our GitHub repository, link in the description. So thank you so much for watching. I'll see you in the next video. Until then, bye.